Hello, this is a quick review of the concepts that we talked about in Unit 3, Algebra 2. The unit talked about applications of quadratics, all right? So basically using quadratics in the real world, okay? So you can answer questions such as, what was the maximum height of an object? Is the object gonna clear something? How high did the object go? How long was it in the air, etc., okay? So a lot of different patterns or stuff in the real world, like kicking a football, throwing something that shows like a little curve, right? Like a little curve area. So these are a quadratic would be a good fit for that. Okay. And usually for the real world problems, we usually look at only just the first quadrant. Okay. So the first quadrant of the of the function, right? So this would be something like, for instance, imagine if I kicked a football. If there's a punter right here and he kicks a football, the football travels up high, goes like this, and comes down and hits the ground. Okay, so that's a model. This model here would be a good fit, like a quadratic model to represent the situation. Right? Usually you can just graph this in Desmos, and Desmos will give you the main points, such as like x-intercepts, the vertex, which is the highest point on here, and and y-intercept. Okay, so you just need to be able to interpret that in terms of the world problem. So for instance, this is at 0, 0, and on here on the notes it says that the x-axis can represent time, horizontal distance, or cost, depending on the problem, and the y-axis can represent stuff such as height, revenue, etc. And anytime the problem is asking you about a maximum or minimum, that's usually your vertex, right? The highest point or the lowest point in a function. Okay, so for instance, in this case, let's say the y-axis here would be the height of the football, and t or x here, let's say this measures seconds in time. Okay, so you can interpret stuff such as if the y-intercept is 0, 0, that means the punter, he kicked the football exactly 0 feet, exactly off the ground, and it went this way. Okay, and let's say this number here is like 3 and 50 or something. Okay, I'm just making up numbers here. So after you would interpret this, that after 3 seconds, right? After 3 seconds, it was 50 feet in the air, which is the highest point, and then it came down and hit the ground. And you can answer questions like, how long did it take to hit the ground? And let's say this point here is like I don't know, 660. So it took 6 seconds for the ball to go in the air, come down, and hit the ground here after he kicked it or whatnot. Okay, so simply understanding, interpreting the function. Sometimes you might have to get the function yourself, all right? But sometimes the function is provided to you and you just need to be able to apply it to that. So here's an example, for instance. If we were to look at a problem, I'll show the answers here so you can work ahead or check your answers. I'll just do, for instance, like this problem here. They're all pretty much the same, but I'll try, we'll do this one right here. Okay, we'll do number 5. It says here, at a pep rally, a cheerleader uses a slingshot to shoot a foam basketball into the crowd, and they give you a function that represents that. So h equals negative 16t squared minus plus 36t plus 5. Okay, so plus 36t plus 5. That's the model, the function that follows that, or throwing or shooting the foam basketball into the crowd. So the first thing you want to do is you want to head on over to Desmos, right? So if you head on over to Desmos and go ahead and graph this, okay? So if I'm graphing this here, just simply type in the function. So y would be the height. So you would type in y equals negative 16, right? Negative 16 x squared, right? So y equals negative 16 x squared, and it's plus 36x plus 5, right? So simply plus 36x plus 5. So once you graph it, usually You can zoom in and out to get a better picture, okay, here. And you can kind of see like here's the main points, okay. And when you click on it, Desmos gives you the main points, or you can zoom in to get a better picture. Sometimes make sure that you zoom in and out. Do not assume that it's a straight line, okay. And if you want to get a really good picture, you click on the wrench and you change the x-axis, right? My x-axis should be positive because that is measures time. So like 0 to 10 seconds, for instance, or maybe you can do 0 to 5 seconds, right? And then the y-axis is your height. So for the y-axis, okay, when you go down here, for the y-axis, I want to put 0 to whatever the height I think it's going to go to. So like, let's say 50. Okay, in this case, actually 25. Make it 35. All right. So once you adjust it, you notice this is a really good picture right here. Okay, so that it measures this model represents the situation, shooting a slingshot, throwing basketball into the crowd. All right. So if you do a quick sketch of this function here, remember you always want to just basically do the first quadrant, right? And then the y-intercept, the foam basketball goes like this, comes down and hits the ground. Okay, so you want to write down all the major points that Desmos is giving you. So if you go back to Desmos, right, you notice that the highest point is 1.12, comma 25, 25. Okay, that's the vertex. You see that the y-intercept is at 0, 5. And then you have an x-intercept. Okay, x-intercept is about 2.4 and 0. Okay, so you have these major points, and now you should be able to just interpret them to answer questions. Okay, and remember in this case, if you're looking at the problem here, the problem said that the y represents the height of this foam basketball, and the x-axis is the time in seconds, like how long it stays in the air. Sometimes this could be the distance, horizontal distance, but in this case, it's time. Depends what it is, okay? So to answer the questions, all right, so if you go back to that page here, all right, so to answer the questions here, the question says, determine the maximum height that is achieved by the foam basketball, right? So the maximum height would mean like, what's the highest point it went on the y-axis, right? And that would be my vertex. That would be my vertex. And I need the y number. So the y number would be 25.25 feet. That's how I would get that, because the vertex would give me that. Okay. So where it says determine the height, the maximum height achieved by the basketball, that would be 25.25 feet. The next one says, suppose the ball misses the stands, like the stands are here, and it hits the ground. How long does it take for it to hit the ground? We said about 2.38 or 2.4 seconds. Okay, so that's where that comes from. Okay. And then the last one says, suppose that a ball is caught 13 feet above the floor. Okay. How long did the ball take? So if I caught a ball here like 13 feet, what is the y number? So I'm simply going to put 13 here for h. Okay. When h is 13, what x numbers gives me 13? Okay. So you can simply put that in Desmos. So instead of h here, you're going to change it to 13. Okay. So if you go back to Desmos, all right. So, all right, so if you go back to Desmos and change the t to 16, okay, so now it says y equals, instead of y, you're going to put 13. And basically your x-intercepts, whatever x value is here, gives you 13. Okay, so when I look right here, one of my x values is 0.25, and the other x value is exactly 2. Okay, so at 0.25 seconds or 2 seconds, this would Okay, if the ball is not caught on the ground, it will say, suppose the ball is caught 13 feet above the ground on its way down by student. How long is the ball in the air? So that means that the ball is in the air. This is a quarter of a second, which is super quick. So this answer doesn't make sense, right? 0.25 does not make sense in this case, right? When you're looking at the x-intercept, so all I did in the equation, I put 13, because if I'm asking if 13 is y, what x's give you 13? So that's your x-intercept. So 1x would be 0.25, but in this case, that's too fast. That's 1/4 of a second. So there's no way the ball can go that fast. So the logical answer would be 2. So 2 seconds would be your answer for that one. Okay, so that's how you would graph it and figure that out by basically putting in decimals. But if you were to solve it, you can use something like quadratic equation or factoring, and you'll able to solve it by hand. So if you're looking at the answer sheet here, okay, I solved it here in the answer sheet by using a quadratic formula. But again, if you don't want to use that, simply type this in decimals. Okay, you're simply going to type 13 equals, instead of y equals, so just basically type that in decimals, because you're saying when y is 13, what x's would give me that, and you'll get 2 answers. And the logical answer would be 2 seconds. Okay, so Unit 3, applications of quadratics, understanding that quadratics models some real world problems, and then usually a function is provided to you. So simply graph that and just understand what the main points in the function could represent in the problem. Okay, so hopefully that helps you guys out. Good luck.